Hi everyone, it's me Daniel Aryee. Welcome back for insightful and enlightening tutorials on the application of mathematical expectation in neuroscience. Yes, today, specifically as first in the series of segment 2's tutorial, we look at how the wonderful concept of mathematical expectation is applied in yet another exciting field as neuroscience, thus an entirely different domain other than segments 1's tutorials, which was specifically centered on investment. Okay, let's go. First of all, neuroscience is about the study of the nervous system and brain, covering how neurons communicate through electrical signals. Neurons send impulses, called action potentials, that allow for rapid communication across the body. Yes, in neuroscience, mathematical expectation provides a quantitative framework to model how the brain interprets uncertain information. The brain often operates under noisy and variable conditions, and neurons process this variability using probabilistic principles. The concept of expectation is critical because, for instance, in decision-making the brain integrates sensory information and assigns probabilities to outcomes. Example, choosing between competing stimuli based on expected reward or risk. Yes, individual decisions are triggered or impacted by certain neurological portions of the brain. Alright, let me further deepen your understanding with this practical examples. Question 1. Decision-making process by Daniel Aryee, November 25, 2024. Imagine an individual in the following scenario, where playing chess gives a reward of 5 points with implied probability of 100%, which is guaranteed for improving cognitive skills of logic, strategy, but involves 1 unit of cognitive effort or cost, also with implied probability of 100%. However, if playing a video game offers 3 points of pleasure but requires no effort or cost, thus 0 cost, what will be his decision? Now for the individual to make a decision of choosing either options, we would have to calculate the expected value based on reward R and effort cost E for both chess and video game using the expected value formula. So solution step 1 for expected value of chess. The formula is given as expected value equals sum of outcome multiplied by the probability of outcome. Therefore, by substitution, the expected value for chess can be calculated as EC equals 5 multiplied by 100% plus -1 multiplied by another 100%. The mathematical representation above can be rewritten as 5 multiplied by 1 plus -1 multiplied by 1. Therefore, the mathematical manipulation of the above gives the result of 4 points as a reward. So now the expected value of playing chess is equal to 4. In other words, by playing chess the individual is expected to derive a cognitive reward equal to 4 points in value. Here it must be noted that the value of cost or effort is regarded as negative in this context, since it ultimately subtracts from the reward. Hence the reason why 1 is negative in the calculation above. Yes, because it happened to be a cost or effort in the question. Good. Now let's move on by calculating the expected value for the option of video game in same manner above. Solution step 2 for the expected value of video game. Again, by using the formula, it implies that the expected value equals sum of outcome multiplied by the probability of outcome. Therefore, by substitution, the expected value for video game can be calculated as EV equals 3 multiplied by 100% minus 0, which is a cost multiplied by another 100%. The mathematical representation above can be rewritten as 3 multiplied by 1 minus 0 multiplied by 1. Therefore, the mathematical manipulation of the above gives the result of 3 points of reward. So now the expected value of playing a video game is equal to 3. In other words, by playing a video game the individual is expected to derive a cognitive reward equal to 3 points in value. However, here it must be noted again that the value of cost or effort is regarded as negative in this context, since it ultimately subtracts from the reward. Hence the reason why 0. Yes, though a 0 ends up subtracting rather than adding to the reward in the calculation above to make a perfect mathematical sense in this context. Indeed, it happened to be a cost or effort in the question, though a 0. Alright, next. Solution step 3, let's compare the expected values for both game options. Thus, expected value of playing chess is 4 points, whereas that of playing a video game is 3 points. Hence, by comparison, the individual is most likely to make the decision of choosing chess, which obviously have a higher expected value if his or her objective or focus is gaining higher rewards. Yet it is important to have additional understanding and appreciate some nuances in the context of neuroscience. Good, okay, now let's dive in deeper and get the catch here, indeed by getting into or considering the following biological processes, yes, specifically the neurological factors influencing and impacting, or better still underpinning the decision-making behavior of the individual above, in other words why he chose chess over video game and vice versa. Alright, good, to this end let's consider the general outlook of the neurological framework for this individual. Yes, multiple regions of this individual's brain will be involved in the decision-making process regarding which game to choose. However, the basal ganglia, also called the striatum, and the prefrontal cortex plays the most significant roles. Thus, whilst the basal ganglia will be concerned about rewards, risks, and action selection, in other words, integrating inputs about reward and risk. Regarding the game options, prefrontal cortex will be responsible for planning, reasoning, and evaluating choices. In other words, it will be involved in the decision regarding the best strategic choice regarding the game options and their long-term benefits. However, other key areas of this individual's brain will be included, as some may play supporting and complementary functions besides other distinct roles or functions. For example, amygdala assesses emotional factors like stress or pleasure associated with the options, whilst anterior cingulate cortex ACC detects conflicts and helps resolve competing stimuli, and also ventral striatum processes reward signals. Therefore, in conclusion, given this neurological processing breakdown, it can clearly be seen that his ventral striatum and ganglia portion of his brain processes higher expected value for chess due to the greater long-term reward. In addition, prefrontal cortex portion of his or her brain evaluates cognitive benefits, biasing the individual toward chess because one, it has higher expected value, and besides, it is obvious that playing of the video game in this context doesn't really add to cognitive skill or benefits because it requires no or zero effort. So in other words, with the details and a possible goal of this individual in the question above, it is now clear or obvious why he may choose chess, which has higher outcomes in terms of reward and cognitive skill, which is implicit by learning through the effort over time, as opposed to playing of video games which required no or zero effort in this context. Yes, the combined effect or impact of the most involved parts of his brain are heavily involved in the decision above by the very mechanics of how those portions of the brain work. However, it must also be equally noted that, if this individual turned to be more pleasure-seeking, thus prefers to focus on avoiding effort or what can be termed as cost avoidance, then with this prioritized objective dominating his mind, it can therefore be inferred that this individual may likely pick the video game above chess because it comes with no cost or requires a zero effort. Yes, in this case, he may have been influenced more by the neurological processing of the amygdala, that portion of the brain which gives him that particular feedback. Now, lovely learners or viewers, at this point let's get into some variety. Good, okay, let's now look at same scenario in monetary framework, since most humans like money, and hence you, my viewers or learners, may easily follow and understand this scenario better. Example 2. Expected value in decision making, chess versus video game, by Daniel Aryee, November 25th in 2024. Right, in this scenario chess rewards the individual with $10 per win, also with implied probability 100%, but requires a cognitive effort equivalent to a cost of $3 per game, again with implied probability of 100%. A video game offers a guaranteed $6 reward per game with implied probability of 100%, but no associated effort cost, in other words zero cost, with implied probability of 100% as well. So what will be his decision? Here, again, we need to use the expected value formula to calculate the expected values of both game options. Solution step 1. Expected value for chess. The formula is given as expected value equals sum of outcome multiplied by the probability of outcome. Therefore, by substitution, the expected value for chess can be calculated as EC equals $10 multiplied by 100%, which is the implied probability, plus negative $3 multiplied by another 100%. The mathematical representation above can be rewritten as $10 multiplied by 1 plus negative $3 multiplied by 1. Therefore, the mathematical manipulation of the above gives the result of $7 in reward. So now the expected value of playing chess is equal to $7. In other words, by playing chess the individual is expected to derive a cognitive reward equal to $7 in value. Here it must be noted that, the value of cost is regarded as negative in this context since it ultimately subtracts from the reward. Hence the reason why 3 is negative. In the calculation above, yes, because it happened to be a cost or effort in the question. Good, now, let's move on by calculating the expected value for the video game option in same manner as above. So solution step 2 for the expected value of video game. Again, by using the formula, it implies that the expected value equals sum of outcome multiplied by the probability of outcome. Therefore, by substitution, the expected value for video game can be calculated as EV equals $6 multiplied by 100% minus 0 multiplied by another 100%. The mathematical representation above can be rewritten as $6 multiplied by 1 minus a 0 multiplied by 1. Therefore, the mathematical manipulation of the above gives the result of $6 of reward. So now the expected value of playing a video game is equal to $6. In other words, by playing a video game, the individual is expected to derive a cognitive reward by earnings. However, here it must be noted again that the value of cost or effort is regarded as negative in this context since it ultimately subtracts from the reward or win. Hence the reason why 0, though a 0 ends up subtracting rather than adding to the reward in the calculation above to make a perfect mathematical sense given the context. Indeed, it happened to be a cost or effort in the question, though a 0. Alright, next. Solution step 3, let's compare the expected values for both game options. Thus, expected value of playing chess is $7, whereas that of playing a video game is $6. So in the final analysis, let's consider the following neurological framework that will impact the decision-making behavior of this individual in the scenario above in a summarized form. Good, a quick breakdown below. 1. Reward processing, thus his ventral striatum evaluates the higher expected value for chess. 2. Effort cost processing, his anterior cingulate cortex, ACC, registers the higher cognitive effort for chess. Now from the above neurological processing breakdown, if this individual values reward over effort, chess will likely be chosen. However, fatigue might bias the brain toward the less effort-intensive video game, in other words, if he is a cost avoidance type. Therefore, in conclusion, yes, though chess provides a higher expected value of $7 as opposed to the $6 expected value of playing a video game, yet the ultimate decision in this particular scenario will depend on the individual goal, thus in other words his current state, thus whether he prioritizes rewards, motivation and incentives over cost avoidance in the context of fatigue, effort, and vice versa. Hence his decision may be taken in favor of either options based on his current preferences or goals. Alright, a quick food for thought. Understand this mathematical expectation model is just as important for individuals as it is for neuroscientists. Yes, for individuals their day-to-day decisions heavily incorporates probabilistic evaluation or usage of the expected value concept, whereas neuroscientists may use the model to study such interested phenomena, for instance on a large scale, in order to understand the decision outcomes of human beings given certain conditions. Once again, I am Daniel Aryee, thanks for watching, and for more videos like this, please don't forget to subscribe to my channel, at D-Technology4. Yes, like and share this with anyone who needs the knowledge. Meanwhile, for more details about the concept and other areas and variation of decision-making, attention, perception, etc., kindly watch the next exciting series at D-Technology4. As usual, keep expanding the frontiers of your knowledge and never ever stop learning. Take care, bye.